Okay, last time we already go through this one. Okay, already done. Okay. Now this is diode. We already done also. If you get a question, let me know. That's telling you one thing. Diode on, they connect. Diode off, they open. No current flow. And that's ideal. Okay. We don't deal with ideal. Second, approximation. Okay. I already talked to you. When the diode on, you didn't see any diode, you have to substitute by 0.7 volt. That's representing for the diode. If diode open, okay, then you can get battery here, but no matter, doesn't matter. Okay. Again, for this diode, the question is diode on or off, we out current I, we got R. So when you see the diode, okay, good thing you're supposed to be no diode here. Okay, what we out?
And 2 volt.
If you don't have a diode here, what we out?
10 volt.
10 volt. Okay, you get 10 volt. So now diode on. If you get 10 volt here, diode on. So now I draw diode. Forget this guy. Substitute diode by the battery. So if you measure at the output here, what you think VL will be?
0.3.
0.7 volt. The thing is VL from this point to the round. You see the battery 0.7. So the answer will be diode will be on. Okay. And diode on or off. Okay. In this case, now VL. What VL equal?
What you want? I'm sorry.
What VL equal?
Oh, okay. 9.3 volts.
0.7.
Oh,
The thing is you measure from this point to the round. Only thing you get 0.7. Okay. Current I equal 10 minus 0.5 divide 1K. That is the formula to calculate it. And the last V got R. V I times R. Okay, you already get I. You already get R. Okay. Or you can do this way. This is the voltage 10 volt. This is the voltage 0.7. VR equal 10 minus 9.3. The next diode on or off.
Off.
Off. The thing is, if you don't have a diode, here will be 5 volt. 5 volt here, ground here. Cannot be higher than 0.7. So that's why the diode will be off. V out. If no diode, you see, you get 5 volt here. 0 volt here. Diode must be off. And what we are equal? 5. Okay. What current I equal? I here.
Maybe 5 divided by.
If you're looking into circuitry, this side 5 volt, the other side 5 volt. What current I?
0.5.
Both get the same potential. Current cannot flow it. Right? Current from flowing from higher potential on the other side. Then you get the current flow. And now you get 5 volt and you get 5 volt. No current flow. What we got are VR.
Five divided by 1K. Points. Open up. So. 0.
0. Both sides 5 volt.
0. 0 amps.
Okay.
So when the voltage is the same across,
0.
it's 0.
Yeah.
Okay.
Voltage on one side have to be higher than the other side. Then you get a voltage. One side 10 volt, the other side 5 volt, then you get a voltage. Current can be flow. But both get the same voltage, no current flow. Okay?
Okay.
Still. Diode on or off. Again, I try to repeat it. When you deal with diode, voltage, if no diode, what we hear,
0.7.
I said no diode.
Should be
right?
five.
Okay, so 5.
Should be 5.
5 volt, correct? When I say no diode, that means they open here. Okay? So that's why you get 5 volt. Okay?
So when it's open before the diode, it's the voltage at the.
Output,
Yeah.
5 volt.
Okay.
The thing is, if you don't have any diode here, that means open. So this is a 5 volt. No current flow. You still get 5 volt here. Okay, now you get a diode E. Now you get a diode E. This side 5 volt, this side 8 volt. Diode on or off. Remember, you get a diode. That will be A. That will be C. The voltage across here, VD, VA minus VC. Okay? If VA greater than VC 0.7 volt, diode will be on. Okay? If VA less than VC 0.7 volt, diode open. Okay? So you get a 5 volt here. You get 8 volt here. The question is, diode on or diode off? Remember, this what we call a VA. This what we call a VC.
VA is greater than 0.7, so it's on.
Diode on or off? One side, VA, they get 5 volt. The other side, VC, you get 8 volt. Can you tell me the diode on or off? Off. If you want on, that means VA have to be greater than VC 0.7 volt. But one here, idea, one 5 volt, one 8 volt, they cannot be greater than 0.7. So the diode will be off. And the current flow, current I here. What current equal? Now you say the diode off. They broken here. They open. Look like now they will be open here. And they going down to 8 volt. If they open, no current flow. Correct? That means the current from 5 volt go up to here. Open. So that means current equal 0. I think the last one. Diode forward bias or reverse bias. Now, if you want to see the diode here, okay, I can draw that for you. That will be A. That will be C. Okay. VA. All right. They connect to the ground. VC equal what? And you tell me what VC equal. Just look into the circuit. VC connect to here. What VC?
100? Negative 100?
Right. Minus 100. Right, they connect to minus 100. Okay, in order to tell the diode on or off, you have to see, you get VD equal 0 minus 100 equal that is greater than 0.7 volt. So diode will be on. Forward bias. Off means reverse bias. Okay, now we go back to the lecture. This is a Zener diode. See the symbol. You know that's a Zener. And Zener diode, they have to get a voltage, they're gonna break down voltage VG. And this is a breakdown diode. We already learned. And they on the top of Zener higher than the breakdown, they cut it down. Okay? And also, Zener can working like normal diode. Like diode we already learned. Okay, this is the normal. If they on, substitute by the battery. That's it. Okay, try to see. We can get through this one. Zener here, they get 10 volt VG. For the circuit show, they given VG. Ten volt. What if V out? If V in 20 volt. Now you get 20 volt. The question is, they want to know what we out here.
It's a 10 volts.
10 volt,
10 volt.
correct. The thing is, I said, if you not get Zener, no Zener here, what we out?
20 volt.
If you don't have a that Zener, what we out?
20 volt.
20 volt, correct. Get better. Twenty volt. And now to get the Zener 10 volt, right? They cut it down. So that's why you only man. Okay? So now you get Zener, they only 10 volt. That's correct. If we in 20 volt, what the current go to 20 ohm. Now you know how to calculate it. You get a current flow here. So I equal 20 minus
10.
divide 10 to 20. Okay. And what is the current? Go to 20 ohm. Okay. Now we in 5 volt. 5 volt.
Yes.
Okay. What happened? If you get a 5 volt, okay, again, if you get no zener, what voltage here?
5.
Perfect. Now you gotta get better. Okay, so basically, without zener, you get 5 volt. All right? Okay. Diode now, not break down. Okay. And they can be working like normal diode. You can see. Okay. I redraw that one. I draw the diode. Negative, positive, ground. Negative, positive, 0.7 volt. Okay. What if we out?
-5.
That means we out measure here, right? From the output to the ground.
4.3 then?
When you get a meter, you measure across the battery. You get that from the battery. So if you get a meter to measure here to here, what you get? Minus 0.7. When you measure the voltage, connect high side, connect low side. High side, you connect here. Low side, you connect down here. That means you connect across the battery. You can be measure minus and then they acting the current through 220. Yeah. So I will be 5 minus, okay, 2 minus 0.7. Negative. Okay. So divide 220. $4.3. Still another problem. Maybe that's the last one. Yeah, that's the last one. The other one was not a problem. Now hopefully you guys get better. You get 24. VG 12 volt. IL 490. For the circuit code, zone for no load. If you don't have a load in here, we don't care about that back here. Okay. Zone for IL. IL, that means the current IL here. That means if you don't have a 490 ohm, what the current flow here?
24.
12.
Okay, now deal with the zener first. In this case, if not zener, what the voltage here?
24.
Perfect. 24 higher than 12.
Yes.
They break down. Break down means you get 24 volt there. No, sorry, 12.
Yeah, go back there.
12.
Yeah, this thing.
Okay, what IL? The thing is the current flow up to this point. They open, they not current not flow through. They going down. That's what they say, no loop. That means the current zero. No current. Okay. IG. IG, that means the current flow here. That IG right here. Okay. So in order to calculate that current equal 24 minus 12. Okay. Divide 470 ohm. Okay. The thing is 470, the current will be flow this way. Go here, 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 go down here. That's it. Okay, the answer we already done. V out 12 volt. V out with the load. Okay. V out with the load. Okay. Now you get the load. You can calculate the V out. IL. RL. Now you have to calculate the IL. So the voltage here is 12 volt. Okay. 12 volt divide 490 ohm. You get IL. Okay. That you get the IL with the load. And they want IG with the load. Okay, so now you can see the current I total when they go up to this point. One go here, IL. One going down, IG. So IG equal IL minus IL. Okay. Okay, just this one, just try to quickly go. We will explain to you how they working. You know this is sideways. They connect inner VG 3 volt. So when the input positive 5 volt, 5 volt higher than 3. You see that? So they break down at 3. Okay. When the negative input applied. Okay. So negative minus 5 here. This is the route. Okay. First thing, did not break down. The thing is break down only when they have to be higher than 3. And now negative part. They less than 3 volts. So they not break down. So if they not break down, we see what happens. On this side, we will go to the negative here. Minus, this is the ground. Okay. That means the diode now will be on. If the diode on, you substitute by battery. See, battery this way. Positive, negative. So this is round. This will be minus positive here, 0.7. So what the V out? When you measure a top battery here and here, what you see?
Negative.
They get minus 0.7. You see that? That means minus 0.7. Okay? So when you're doing a simulation, MC7, easy, right? Draw that one to run it using the meter to measure, no big deal. Okay? We'll get to that. This one just opposite. And now, if they get this circuitry with D1 and D2 connect this way, then the output coming out, okay, for positive, then you can get this signal. For negative, here, you get this one, okay? This is the opposite, okay? Will be get the simulation for you guys to go to working on, okay? Same thing. Now, light admitting diode. Okay, you can see the light Okay, they can turn on, turn off. Okay. And now also this is a 7 segment. That means they will be converted to number decimal. Okay, or A, B, C, D. Okay, that's a segment. Now, halfway rectify. This is a circuit halfway rectify. You can see this is a sine wave, full wave. When they go to the halfway rectify, they only have positive, no negative. That's what they call halfway rectify. Now, see what's going on here. You get a rectify here, halfway. That is a full wave. Okay, so they go to the filter. Okay, so basically you can see this signal 0 volt filter. Okay, complete power supply with rectify. You get filter and regulator. Okay, this is a filter, and you don't see the full wave here. You can see they get a ripple here. Go to the regulator. They given you DC voltage. Okay, so basically they need the circuitry if they want DC voltage. Okay. Halfway rectify. Now they go to detail here. You get the input here. This is a diode. These are the nodes. First thing you see VE. Positive, negative, positive, negative. Sorry. When they go to the diode, they suppose diode VD equals 0. So we're not talking about 0.7. So when the positive here, this a positive. This signal will be go through the output. You get this part here. When you get a negative input, negative here, diode open. Okay. Diode open. You get 0. Positive, you get it. Negative 0. That's why they call it halfway rectify. They rectify only positive, not negative. Okay, so input frequency equal output frequency. Second approximation, we pick out equal we pick in minus 0.7 volt. Taking it up to the point, I will using the MC7. Run it, you can see right away. Okay, that's easy. Next one, transformer. This is a transformer. This is a transformer. Transform 1 voltage to the other. Transfer the 1 voltage to the other. Okay. Primary voltage VP. Secondary voltage VS. That means primary. This is secondary. MP. Number of turns in a primary. And add number of turns in secondary. How many turns they can make transformer. Okay. you get the formula NP over NS V equal VP over VS. Then you can calculate VS equal NS times VP divided NP. If NS greater than NP, that's what they say step up. That means you apply input lower voltage, output will be higher. Okay? Or step down. You understand outlet voltage here. How many volts? 120. All right? 120. However, the wire run outside 400. Okay? They have to get the step down transformer. So when they go up here, they get only 120. That is the purpose of transformer. Okay? For example, inside the computer, they also get the power 12 volt. But the voltage coming in is not 12, higher. They need the transformer. Okay? Transform down to the voltage you want. Okay? If the VP higher than VS, that means step up. Okay? If the VS higher than VP, step down. Okay? Up and down. Now, you can see that one. This transformer Q1. Okay? That means the wire on the primary to the other V1. For the circuit cell determine the peak taken voltage be taken. Okay? And you understand on that one. VP be second. Okay? Let's see. V peak equal V peak in equal 156. Then V second equal V peak in times 1 over 2. You get 78 volts. The formula you already know from this one. Okay? And they want V peak out. Okay? V peak second minus 0.7. That only telling you when we pick here, from here, it will be 78 volts. However, they want the V peak secondary. They be here. Okay, if you get a 78 volt, diode will be on. And when they on, they get positive, negative, positive, negative 0.7. Okay, so that's why they take a V peak minus 0.7. You get 77.3 volts. Frequency output, okay. Input frequency 1K. Output will be the same frequency. Okay. That's for transformer. Now, that one. Full wave rectifier. What that means? You get the input here, positive, negative. Okay. Now, this is a primary voltage. When they go to the secondary, and now you get the ground in the transformer. Okay, connect to the ground. That means they divide by 2. So DC average VDC equal 2 times V peak. Okay. F out. F out. This is the output here. Frequency will be double. Input frequency. F out equal 2 times FE. Ideal. Flip flop equal 0. That means we don't need 0.7 volt in here. Practical diode 0.7 and VP equal VE minus 0.7 we pick out. Okay, so basically on this kind of the circuitry, I will be working with you in MSIM7. MSIM7 is real. We can use in the meter, we can use in oscilloscope to measure. In here, just a theory. Okay. Only thing is, if I see the input look like, and this is the output, I know this is the full wave rectifier. They rectify both positive and also negative. That's what they call full wave. Okay. This is just a more detail. Okay. On that full wave, they given you more detail. Okay, whatever here. Full wave rectified. That's what they given to you. They prove the full wave rectified a half here, how look like, a second here, how that look like. Okay, when they go out, they get this signal. And the V peak divided by 2 minus 0.7. Same thing, more detail. Okay. Okay, break rectifier. You see, this one, positive, output positive, negative, output positive. They keep doing the same. That means full wave rectified. However, they're using only diode here. That's what they call a break rectifier. Okay. That means when positive, which diode will be on. Okay. Now, they given you here. Input positive. Okay. That's telling you diode D1 on, D2 on, D3 and D4 will be off. So that's why they given you this signal. Okay. And now, when you get a negative, then D3, D4 on, they get another positive. Okay. Break rectifier. Okay. capacitor input. Now that's just for your knowledge. Okay, we don't need that. Okay, so that up until this point, they done for the second board you're working on will be what?
Semiconductors.
No, what the circuit board after you get DC. And
Yeah,
what circuit you're
AC.
working on?
DC. AC.
Semiconductor.
Semiconductors.
Oh,
Okay, semiconductor. So basically, you understand me. I change the way spending after 5 years. That means from 90 and now 26. Before we're talking only online. And the time working on the lab, not. So that's why I change that Monday to Thursday to working on the level. Try to get through the level as much as you can. Okay? And the lecture we can give them you in the class. However, I still record it. Okay? I will be uploaded to Canva for anyone want to see over. That'd be fine. Okay? And again, if you can understand, that means keep moving. Not only technician. If you keep growing up, I can guarantee someday you can be engineer. No big deal. Okay? I already been this program for over 40 years. Okay? I already get a student. They already be engineer. Some asking me, offer for him to teach it. But we don't have a chance. Okay? But now, 2 engineers graduated about a year ago. And now he's working for Intel in San Jose. And another one working on Knock Rock, Austin, Texas. You know what they get paid? $250,000 a year. Gee, too big. My time I'm working on an engineer, I get about 120. Long time ago. Okay? So if you can understand what's going on here, then you keep moving. I can guarantee that. Okay? You want to be a technician. What I want to say when you're working on from the semiconductor, right? Using more equipment. And you can do it, no big deal. That will be require generator. That require oscilloscope. Okay? Require how to connect the circuitry they want you to do. Okay? Then I can guarantee no big deal. So, again, no class anything this Friday. No class on Monday. Holiday. Okay? So when you're coming back, will be on Tuesday. So you will be working on level. And I still be here on Thursday, Wednesday. I see. Maybe I can help you, okay? You're working on the level. to speed it up. Okay? I don't even you that. Have a hard time working. You do it, you not quite follow. Thank you, mate. I can be online with you just a few minutes, can solve the problem. You get assignment number 7, cannot pass. Okay. Thank you, mate. We on you. Just about 10 minutes solving that problem. I just try to help you to understand. I don't want to make sure you cannot pass the course if you keep doing it. Okay? So, any question? Remember, we close the class at 7:50. So now you can going back to the lab. Okay? Try to do as much as you can.
How far did you get?
You know, you want to push it. I ended on